This video is of me going through the process of making an FSK modulator for the JPIC. Due to mistakes, I accidentally introduced bugs into the code. You'll see the unedited puzzlement and frustration as I try to figure out what's gone wrong. So keep a keen eye out and see if you can figure out the bugs before I can. We'll start up Qt Creator. We will create a new project, other project, JPIC applications, and we will call it FSK mod 2. Configure it for the JPIC device. We will then delete that, we'll delete that. Now we'll go to the PRO file, and this example we're going to configure it for audio. Now I haven't told you how you know what various things you can configure it for. The configurations in Qt in QMake are done using what are called features, and this file here is this bootloader reserved memory is in the same directory. So if we go right click on it, show in Explorer, we see the features folder, and this PRF file, which we can open with a text editor, is how the features are done. So for example, what one have we used? We've used OLED before. So OLED is a feature, and it includes OLED driver.c and OLED driver.h. So if you do want to know what any of these things you can configure, they're in here, and you can add other ones. So we want to configure it for audio, and we also want something called the wavetable, which is a numerically controlled oscillator, a complex numerically controlled oscillator. This little backslash up there means a new line. Well, it means configuration is audio and wavetable. We now want to include the header files for both the audio driver and also the wavetable. Things like the wavetable and ones like that I've actually put in j.dsp. For the big drivers like the audio driver, they're just in their own directory. So we want the wavetable. If you don't know what directory they're in, you can have a look in the in this PRF file, and you can see wavetable is included in j_dsp. You don't have to worry about the source thing. While audio driver, the audio driver is under audio driver. So for the audio driver, control left click on the audio driver, we see a simple example. So we might as well copy and paste it. Copy and paste. I can highlight that and press Control \, gets rid of those, and Control I, auto indent it. This I am actually going to make something else. I'm going to call it audio code, say, and I'm going to make a couple of defines. The audio code I'm going to define as audio sample rate 44k. I'm also going to define something I call FS, which is the sample rate in the sample rate is an actual number in hertz. So the difference between audio sample rate 44K.64 and that one is that this one is just a code. You can see it's just a number that tells the audio driver what speed it should be working at, but these ones with _FS actually contain their sample rate in hertz. So that means I can just say audio start audio code. Now for the wavetable, we need to have a look at the example. We can see we initialize it like that, step and do something. So we'll copy this part of the example. Again, get rid of that. Now, for this example, I'm planning on making it some sort of FSK modulator. So we'll take the user input from the PC and we'll modulate it for an FSK frequency. So for that we first need a wavetable that is makes the noise, the sine wave, and that will have two frequencies. It'll have 1200 and 2200 hertz. So to prevent phase discontinuity as we change between one frequency and the other, we can initialize this twice, once at the low frequency, once at the high frequency, and we can save the 32-bit integer frequency low. We can save the frequencies as just a 32-bit unsigned integer. I know that because if we have a look in the initialization code of how this works, I have to build it, this will come up with an error. We'll get rid of that. And if we go to left click controller, it says set frequency here is just setting the phase. What it calls phase is related to the frequency. So if we save phase, we can save this frequency for later. So wavetable.phase will be a number that the wavetable steps every time you update the wavetable. So we want a low frequency and a high frequency. So I know this because, say here we update the wavetable, which is wavetable step. What is it? If we forget, we can go control wavetable. We can see the example is wavetable step. So wavetable step. If we look in wavetable step, we can see the accumulator is increased by the phase every time, and that's all the wavetable is actually doing. It's just increasing the accumulator. Then it wraps around once it gets to the end. So the phase is the frequency. Well, this variable called phase represents the frequency. So that's why that works. So we've created a frequency. We don't need the analog to digital converter. We're not using it. We're also not using any of that. Now we also need a symbol timer, which is just another wavetable. We'll call it a symbol timer this time. And we will initialize this symbol timer to be our symbol rate, which we will want to be 1200 baud. Now, for a symbol timer we could just use wavetable.step, but in this case we will use wavetable step, no value. It's just the difference between the two is that you can see the difference between the two. I have a look in there. This calculates the sine value, the sine and the cosine, and accumulates the phase gets accumulated to the accumulator, compared to no step, which is no value. It just doesn't calculate the that, so it's slightly faster. It's because the symbol timer, you don't actually need the sine value. So that will increase that. Now for the audio out, which is here, the contents of the audio out, we want to be the wavetable value, and the real value will be fine. It makes no difference. Now at this point we want to do something when the symbol, when we get a new symbol. So we have to detect that. So if the symbol timer accumulator, which is the thing that increases, is less than, that's a 32-bit integer, so that means we should have 1, 2, 3, 4. Yeah, I got one too many zeros. 4, 4. And if we do uint, what else have we got? It's 32 bits. Last symbol time accumulator will equal symbol timer dot accumulator. So here what we're doing is we're going to check for the wraparound of the wavetable, which once it gets up to all ones, yeah, if however many, it will then go back around and go to a low number. So 8 with all those zeros is halfway. So it means it's gone from the upper quadrant, the upper half, to the lower half, and as it's always going up, that means we've detected that's past that's wrapped around. So what else do we have to do? Well, we have to get symbols. So we need symbols from the user. So we will, how we'll send this is we'll have to make a buffer. We'll make these 16 bits. If we make them 16 bits, this will be some that will allow us some room for the user to press characters while yeah, I mean, we need some place to put it. Now to get characters from the getchar, which is the normal thing that everyone uses, doesn't actually work very well. So I just modified it ever so slightly to something called JGetchar, which is just very, very simple. But it works unlike getchar for some reason. I don't know why it doesn't work. So if the user presses a button, and if pointer, if there's space in the buffer, then we will place in the buffer and we will increase the index so that will get the user data into the buffer, which will give us something for our modulator to work with. We will then, okay, we have to, what should we do next? Mind blank. We have to have a look at the char pointer, so we need another one which we'll call char bit pointer, and we'll call that 0. Now if we have something to send, then we'll do this. Else, if we don't have something to send, then we'll make the wavetable its phase, which we stored previously, equal the high frequency phase. That's because if we look at what the UART signal looks like, we can see it goes high, then there's a low start pulse, there's another 8 bits of data, forget about the parity bit, and then it goes stop for 1. So we need this. So far we've just put this in our buffer, but if we put this and this in our buffer and we send 10 bits rather than the 8 bits, so if we change this, typecast it to a 16-bit, we shift it up by 1, which gives us our stop bit, which is a start bit. Oops. Stop bit is high, start bit is low. No, it's our start bit. Start bit will be low, so then we have to, that will be the second bit in the, we have 8 bits for where this used to be 8 bits, we've shifted it up, so we've got 1 bit, but it's 1 in front of this HR thing. So that should match this format without the parity bit. Now we've got 10 characters in each of them that we send, so if this is full, we want to have a look. So if we will put character buffer 0 ANDed with 1, which will be the first bit. This is if we want to send a high or a low, so we will send a high if there's a 1 on it, else we will send a low, which is a low frequency. Then we will increase the bit pointer, and if the bit pointer is greater or equal to 10 bits, we've sent 10 bits, it's time for the next character. So we then have to reset the bit counter, and we will shuffle all the, we could do it differently, but I'm just going to shuffle all the things in this char buffer down by 1. So oops, for int k equals 0, while k is k is less than this, and nope, we've got 64, so 64 take 1, k plus plus, we will make this equal that, yeah, k plus 1, so that shuffles them down. It's a bit slow, but okay. Okay, so if the bit pointer gets too big, make it down, shuffle everything down. Now we've got less of these, so we want to subtract 1 from there. Okay, how are we going? I think that's getting there. So this part here gets the characters, shifts them up, puts a 1 in that place, 0 in the last place, which is the first one we send out, so it's least significant bit first. We catch when it loops around, when the audio, when the wavetable loops around. If the char buffer point equals, so that's if we've got something to send, we send the least significant bit first. If it's high or low, we increase our bit. If there's too many, if we've sent all the bits clear, shuffle down, and hopefully I've got that right. Now another thing we can do is the sample rate, sorry, the UART rate from the computer is about 1 meg. That means we can send characters really fast to this thing, but it would be nice to slow it down. So how do we slow the UART down? It's already been initialized. We now need to figure out how to do that. So I don't have any real driver for that, so let's go to Start, Programs, Jade, User Documents. Now for the user documents, these are ones I've just added. This one here is the main place to start, where everything is the first port of call you should go to. And it tells you generally about the main microcontroller on the JPIC. So in this case we're interested in UART, so we go down to UART and it says to complement this information, refer to this document down here. This document about UARTs, we then have a look. If we can find it, all these things I'm looking for. Oops, don't need to open that. User document. There is none. If you look through here, I don't have anything about UARTs or have anything that mentions that reference number. So what you do, or what I do, is I go to do an internet search for that number, and it's almost always the very first document. And you can see we've already configured it, so really, well, the bootloader's already configured it. So all we have to do is recalculate the baud rate generator for the UART. So I'll use this one. It says if BRGH is 1, then you can use this formula. You find a calculator. We want, say, 1200 baud because that's what we're sending it. It says FCY is the instruction clock cycle, which is 40 million, divided by 4 times 1200 plus 1. Okie dokie. I think I got that right. Oops, minus 1. Minus 1. We take that number, and what was it called? that was called UXBRG. X is just a placeholder for the UART number. In this case it's 1. U1 control space BRG, there it is, 8332. Now it says that BRGH equals 1, so we can go back to here and look for, here it is, BRGH. So this is will be in U1 mode. So we can go into here and put U1 mode. We want bits because we want to control each bit individually. BRGH and equals 1. So that will configure the UART for 1200. It's not strictly necessary, but if we've got a bit rate of a baud rate of 1 meg, you can rapidly fill up this buffer. At this rate, you're not going to fill up that. You shouldn't fill up that buffer. Well, not very quickly anyway. So we'll give that a go. We will build it and run it. See if there's any errors. And we'll burn it. Now, as we change the bitrate to 1200 baud, we have to select the slowest, not the default speed, and then go over to the console. So if anything I press on the keyboard now gets sent to the JPIC. Now I found one program, this program, that can demodulate this this sort of speed. So if we choose the microphone, there's our signal. It's 1000 shift. We're getting stuff there, but nothing's happening. So we've got an error in the program. Frequency high, frequency low. This is odd. Sample time, is that right? Frequency high and it's frequency low, so what's happening there? Somehow frequency high equals frequency low? Not that I can see. Wave sample initialized 12. Whoops, there's the problem. Symbol timer 1200, that's correct. Symbol timer, okay, let's try that. Okay, but it's still not working. Anything I press is not happening. So what's happening here? Step the real deck step the. Well, there's my problem. That should be before then, otherwise last symbol time accumulator will equal the same value and we'll never get into here. It's the thing, even the simplest little program, there's always something you have to think about. Right, this time we've got bit rate, yep. So no, that's still an error with it. Simultaneous accumulator. Where are we using this? Okay, that is odd. Okay, so we need to do some debugging. First off, are we getting anything here? So we'll do a printf statement just to make sure that we're getting something. Okay, that's all. This accumulator is less than a 1, 2, 3, 4. So it's getting the bus equal. Amateur hour. Okay, so what we've forgotten there is we have forgotten to shuffle the bits down. If we don't shuffle the bits down, we're only just getting the first start bit. So I won't put that there because I think that's burn it again. Okay, so now at least we've got something happening. Nothing happening. Mode 8 bits. So we've got mode, shift. Okay. And we've got nothing on normal and oops, and nothing on reverse. So what are we down here? Bit rate's correct. Okay, we'll add that debugging to it. Okay, numbers are getting through, so there's no problem there. That's not real value, low step. Okay, I am going to have to figure out what I did wrong. Why doesn't that work? symbol timer. Very strange. How do I clear that screen? Clear? No. FSK, yeah, I don't know. Okay, there's my problem. I had the wrong kind of OR. So with I had, what is it, logical OR? Whichever's the wrong. I want to put these two numbers together, not make the statement this or that. So we'll burn that to it. And now we're looking like this is working. So we can do, this is a test, and we have finally made an FSK modulator. So I hope that was useful. The sound of it, let's see, can you actually hear it? Not sure. If we go to, well, I have to start up the program. Oops. Yep, there it is. It's this one. I don't know if you can hear that. Oh yeah, you will be able to. So it just sounds like FSK. So I hope that was helpful. I had a few problems, but that's pretty standard with these things. Anyway, that's all.